So sometimes we have to use these properties, like in question number 14, to write these as a single logarithm. See, this one was a single logarithm, and we broke it up into a bunch of stuff and made it into 4 terms. But sometimes we want to get it back into a single logarithm. Well, when there's a coefficient out in front, we have to take that back up as an exponent and call that m squared. So we have to call that the log of m to the second power, where the base is b. And see this 1/2? We have to bring that right there up here as an exponent on this n. So we have to write that as the log of n to the 1/2 power. Please remember that anything raised to the 1/2 power means the square root of that. So I'm going to erase this, if you don't mind. And n to the 1/2 means the square root of n. And finally, I'm ready to put this together as a single logarithm, but because it's an addition problem and logarithms behave like exponents, then it must be a product. So this is the log of m squared times the square root of n, where the base is b. And I have written this as a single logarithm. So that will be the definitions. Write this as a single logarithm. Let's see what the next problem or 2 presents. So same thing, but let's work inside the parentheses first. So let's do this and write it as a single logarithm, and then we'll make this as an exponent of a 3. So with subtraction, we know this means division. So this is x divided by y, where the base is a, with a 3 out in front. That's now how I'll be able to bring the 3 as an exponent on these 2. The log of 2x is good to go. It doesn't have a number in front of the word log. So when I'm ready to write this as a multiplication problem, because of this plus sign, that will be good to go. But this 3 has got to be put on the outside of the x, y, and it's got to be thought of as its exponent. So now the 3 has been moved. Now remember, the log of, x divided by y cubed means x cubed over y cubed. So remember that this right here means x cubed over y cubed. That's what that is. So I'm now going to write this sum as the product of 2 things, one being the 2x and the other being x cubed over y cubed. So finally, I got to do my algebra. So 2x times x to the third is 2x to the fourth, because this has an x to the first, and I add those exponents over y to the third, and my base is a. I can put parentheses around this, but if you write it neat enough, you kind of don't have to, as long as it's understood that this is the log of all of this. Check out this next problem. So it's got a minus sign, so they want us to write it as a division problem, a single logarithm. So they want us to write this as 2x plus 10 in the numerator and x squared minus 25 in the denominator. And the base is a. Whatever you do, don't stop there. You know how to factor algebraic expressions. This is a rational expression. I would expect you to recognize that there's a greatest common factor of a 2 that can come out of that, and you'll have 2 times x plus 5, because that's equal to 2x plus 10. And this is the difference of squares. It factors into x minus 5 times x plus 5. So I want you to see that this algebraic fraction can be reduced because there is a 1 that can be pulled out in the form of x plus 5 over x plus 5. That's equal to 1. So you're left with just 2 over x minus 5. So this should be simplified to the log of 2 over x minus 5. Again, where the base is a. And parentheses would be nice, but I would not mark you down for that. Write each expression as a sum, difference, or multiple of logarithms, and then evaluate it. So this one, I'm asking to find the log of 3/8, but what I want you to do is to take your calculator and take the log of 3 and subtract the log of 8. I actually didn't do that beforehand, and I'm going to do that real quickly right now. So the log of 3, and you know what? I'm going to actually write these numbers down. The log of 3 is 0.477. The log of 8 is 0.903. So when I subtract 0.477 and then take away 0.903, I get a negative 0.426. You could also take on your calculator, just hit the log key, open parentheses, 3 divided by 8. Please don't type log 3 divided by log 8. This is not a change of base theorem. You just want to know what the log of 3/8. And you know 3/8 is 0.375. So you're just looking for the log of 0.375. And that is equal to this negative 0.426. Here, this one, however, this is one that you could do in your head, because if you wrote it as 2 terms, the log of 100 minus, the log of 1 minus the log of 100. Remember, the log of 1 is always equal to 0, because you're trying to take some power of 10, and you got to raise 10 to the 0 power in order to get 1. This is a 10, because it's understood to be 10, and 10 has to be squared to get 100. So this problem is just the number 0 take away 2, and it will give you a negative 2. But if you hit the log key, and if you opened up parentheses and put in 1 divided by 100 and closed parentheses, it should give you a negative 2. Again, it's because a base of 10 here has to be raised to the negative 2 power in order to get 1 over 100, because 10 to the negative 2 is 1 over 10 squared, which is 1 over 100. So sometimes you could just see why it's true. This one is asking you to evaluate by thinking of the cubed root of 6 as 6 to the 1/3 power. And then it's asking you to take this exponent and bring it down in front and think of it as 1/3 times the log of 6. And then just type that on your calculator. And when you do, you should get 0.259. So 1 divided by 3, and then hit your times key, and then log 6 and hit equals, and you'll get 0.259. But you could also type log, and then you'd have to hit your math key, and then I think it's menu item number 3 or number 4 that says cubed root of. So you'd hit that key, and then you'd have this on your screen, and you put a 6 in, and that should give you 0.259. So again, these problems asked you to write each expression as a sum, difference, or multiple, and then evaluate. So we did. Let's see. We might have time for this last question. Sound levels are measured in decibels, and the intensity of sound is often compared to the lowest intensities of sound that the human ear can identify. And it's a logarithmic statement. It said the loudness of sound is measured in decibels is given by this formula: 10 times the log of the intensity divided by the minimum intensity. So where I is the intensity of the sound, it is not the decibel level, it's the intensity of the sound measured on the tympani or the membrane of a sound meter. And I sub naught is the intensity of the faintest sound. So let's say that a busy street has a noise level whose intensity I is 10 to the 7th times the most smallest sound, the faintest sound we could hear. Right here for I, I'm going to plug in 10 to the 7th times I sub naught. Let's do it over here. So we have 10 times the log of 10 to the 7th times I sub naught divided by I sub naught. Well, dang, those I sub naughts can be removed because they're equal to 1. So this sentence is now 10 times the log of 10 to the 7th power. Well, I'm going to make this easy on myself, and I'm going to bring this 7 down in front right here, and this will now be 10 times 7 times the log of 10. But please remember, the base is 10 in this problem because it's not written. And the log of 10 where the base is 10 is equal to 1. So finally, my answer for this problem is 10 times 7 times 1, which is 70 decibel levels. And I can tell you, when you hear me in the classroom, I'm pretty loud, and I'm probably talking at a decibel level of between 40 and 45 maybe. So 70 decibels is quite loud, but I want you to know there's a problem in our homework. I believe it's in this section where it says the sound of a jet engine. If you were standing in front of that jet engine, so here's the engine, and you're standing right here, the sound coming out of that jet engine is 100 decibels, and that's killer. You see people on the tarmac wearing earmuffs for a reason. Their ears cannot tolerate 100 decibels of sound on a regular 8 hours, 10 hours a day basis. So 70 decibels is quite a lot, but it's not a proportional thing. 100 decibels is killer. So I'm talking at 40 or 45, a busy street is 70, and this is going to hurt your ears, practically, if you're standing right in front of that engine. So it's a very interesting topic, and it is dealt with in the terms of logarithms. More applications to come in class.